Hello and welcome to Module 4 of Multivariate Statistics. It's hard to believe we're here already. Module 4, so just to recap, Module 1, getting started with the software, either Stata or R. Module 2 was a review of regression and ANOVA. Module 3 was advanced regression and moderator analysis. And now we're going to spend a little time talking about advanced ANOVA and ANCOVA models. So we're really going to dive into ANOVA this week and learn hopefully some new things. All right, so let's talk a little bit about using ANCOVA. All right, so the main reason that we are learning about repeated measures, or the main reason we're learning about advanced ANOVA models this week is to better handle situations where we have repeated measures. So let's talk a little bit about what repeated measures are. Repeated measures occur when you collect the same measure, for example, attitudes, motivation, beliefs, grades, temperature, it could be anything, right? From the same person more than once, and usually over a defined period of time. This is also sort of called longitudinal data. And when we do this, we usually violate a very important assumption of most regression and ANOVA models, the basic ones, which is the independence assumption. So if we were to just take all those repeated measures and lump them all together and throw them into an ANOVA or a regression, the assumption is that all of these observations are sort of independent and identically distributed. So the fact that the same measurement comes from the same person many times over is a violation of that assumption. And so, in other words, the same person really can't count twice in your sample. So if you have repeated measures or longitudinal data, you need different kinds of methods. And this is important because longitudinal data can actually be really useful and powerful. For me, it's some of the most interesting kinds of data that we can collect because it really helps you learn a little bit about change and how people change over time and how things change over time. And it can really answer some cool questions that you just can't get or get at from a cross-sectional or one-time data collection. And so we need a little bit more specialized methods to handle those situations where we have repeated measures. And one of those specialized methods is analysis of covariance, or ANCOVA. This is actually kind of a special case of ANOVA and regression. It's kind of like the perfect union of ANOVA and regression in some ways, and it can be really useful. So what an ANCOVA model allows us to do is it allows us to test for group differences. And anytime you hear group, right, ANOVA categorical variables should be kind of pinging in your head. So it allows us to test for group differences after controlling for a continuous confounder. And that is regression, right? Controlling the idea of variable control or controlling for a continuous variable is very much a regression concept. Ideally, as with ANOVA analysis, it works best when you have random assignment to groups. So the sort of experimental paradigm, it tends to work a little bit better. You get the least biased estimates. But in a lot of ways, it really works like multiple linear regression. So we've learned and we've talked a little bit about multiple linear regression last week and the week before. And an ANCOVA model is really a multiple linear regression model, but a special one where you have one categorical variable, which is a factor. That's the ANOVA part. And you have one continuous variable, which is your covariate. So this is kind of a specialized ANOVA regression hybrid that can be really, really useful in very specific circumstances. If you do have random assignment, using an ANCOVA model, as opposed to an ANOVA model, where you're not controlling for anything, really reduces the noise of your estimates and makes it easier to find an effect. So this, from a design perspective, is one thing that's really useful to think about. If you can design a study that makes use of an ANCOVA, it can really make a big difference. And here's a visual that kind of demonstrates that. So here we have a typical ANOVA design. And remember, when we estimate an ANOVA, we basically have two kinds of variability that we're looking at. We're looking at between group variation. This blue part right here, that's our signal. That's the good part. It's the difference between groups that we hypothesize might be there. And then we have the within group part, and that's really the noise, right? That's kind of the random variability within groups. And both of those components are present anytime we run an ANOVA. And our hope is that the between group part is big enough that we can detect a signal and find a significant difference. Well, in ANCOVA, it's pretty interesting because what happens is when you introduce a covariate into the model, that is in theory related to your outcome. So think about like a pretest, for example. If you give a pretest and then a post-test, and you try to estimate the pretest controlling for the post-test, what happens is that covariate actually absorbs some of this red variation down here that would otherwise be noise. So the variability that once was noise in the ANOVA is actually absorbed by your covariate. And that actually makes it easier to find between group differences. And that's why it's so powerful often to think of having covariates in the model. Not only can they control for confounders, right? They can help explain other plausible hypotheses that might also be related to your variable of interest, but it can explain away variation that otherwise would make it harder to find a significant effect. And so, in a lot of ways, an ANCOVA design has a lot of power. It can increase the power of your analysis and make it easier to find the effects that you actually want to find. So let's look at kind of a classic example or two of when we might want to use ANCOVA. Okay, so let's say we're studying some kind of an intervention. It could be a classroom intervention. It could be a therapy intervention. It could be an intervention in schools. It could be in, anywhere. And you are able to administer both a pre-test and a post-test. So it doesn't have to be a test of ability or cognitive functioning. It could be attitudes. It could be beliefs. But you believe that your intervention is going to cause some kind of change in whatever it is you're measuring pre to post. So this is pretty common, right? This is a situation in research that we encounter a lot. You believe something is important, right? And you think it causes changes in human behavior or human beliefs. And you administer this sort of treatment and you want to look for change over time. This is basically what we would call a single group pre-test, post-test type intervention, right? Or if we are able to randomize, we actually can have a multiple group pre-test, post-test randomized intervention. So some folks get one treatment, some folks get another treatment. I know sometimes there are ethical considerations around sort of a control group and what it means to not get a treatment. So maybe one group gets business as usual, the other group gets some kind of a treatment that you think might be important. But notice before and after, you're administering a pre-test and a post-test. So you're able to look for some kind of growth. So what this basically is, this is a pre-test, post-test, randomized to groups intervention, and it is perfectly set up for using an ANCOVA. Because what you're doing is you're going to predict the outcome, which is the post-test, after controlling for the pre-test, and that's the growth component. That's where the growth component comes in. And after you've done that, you can then see if there are group differences between those who received one type of treatment versus another type of treatment. So very clean, very simple, but elegant in a lot of ways, because like I said, you're able to control a lot of that variability that in a typical ANOVA design, you wouldn't be able to handle. All right, so a few things to consider in this kind of an approach. If you're able to successfully randomize to groups, you actually can use ANCOVA to make what we would call causal claims, right? Anytime you're able to sort of randomly implement an intervention and it actually is successful and the randomization is successful, we typically can make claims that your intervention actually caused a change in beliefs or behavior or achievement or whatever it is you're measuring. If not, if you're not dealing with a randomized case, it's the same sort of assumptions that you would think about with a regular regression model. These are not causal effects. You may have some covariates in there and you're controlling for things, which is good. But we typically don't think about it. We think about it more as an association and not a true cause in the sense of causal inference. Another thing to consider, of course, is that an ANOVA design really significantly increases your power to be able to detect between group differences. So if you're designing something, right now, many of you are kind of in the phase where you're thinking down the road about dissertation. If there is a way that you can include either a pretest or a measure that can control a lot of variability in your outcome, that can significantly increase your power. And power is really important, right? Because it's hard to get people to participate often in research. And so any sort of design consideration that we can put in that allows us to essentially need fewer people is a really good thing. Now, perhaps the most important consideration. An ANCOVA is like, I wouldn't call it a Swiss Army knife, like something like multiple regression. It's like that really specific tool that you have in your toolbox that does one thing perfectly. Like I'm thinking about, I have to change the air filters in our house, and there's only one little tool that I have that I keep in my toolbox that actually can remove the pins to actually change the air filter. And ANCOVA is kind of that sort of tool, in that it has to work in a very specific situation. And that is when you have only two measurements, right? Pre-post is the most common case of that, two measurements, and one categorical variable where people are assigned to groups. So that's the situation where this works. Otherwise, you need fancier methods like repeated measures ANOVA or multi-level modeling or other things. But if you only have two, it can work really, really well. Okay, so a little bit of setup here about the data set that we're going to use for this. The data set here comes from Michael Mitchell's pretty recent book, Stata for the Behavioral Sciences. And I know not all of us are using Stata, but this actually is a really nice book. You find a lot of ANOVA designs in the behavioral sciences, clinical or more lab-based psychology tends to pop up a lot. And so a lot of these examples come in are sort of in that more like clinical psychology realm, but not necessarily all of them. And the data set we're going to look at for this week is a kind of a classic ANCOVA design. We have 82 folks who participated in a trial of new therapy that's focused on encouraging optimism. And the outcome here was happiness. So kind of looking at happiness before, happiness after this kind of randomized optimism treatment. There was a treatment and control group, and after that period, people took a pre-test and a post-test. And what's cool is in this book, you actually get two versions of this data set. One, you have a true pre-test, post-test, but in the other, you just have a related measure. And I think that's a cool example just to show you that you don't always have to have a pre-test. You can, in the situation where you're randomizing to groups, you actually can have a related measure that can help explain some of that variability too. So we'll look at that example. I just want to point out too, I have some examples here in the slides of a sample APA write-up for ANCOVA. So this is that. This example here is what I'm going to do in the demonstration video, both in Stata and R. It's the ANCOVA model for the optimism therapy. And this is how you might write it up with, the F-test and p-values and effect sizes, eta squared and so on and so forth. So that can be helpful to you. You also can do some post-hoc contrasts as you would in a typical ANOVA model. And so I write up how to do that as well. Okay, so that's part one of our video. I'm going to pause here. And in part two, we're going to get into another tool. So this, just to summarize, we talked a lot about the advantages of using analysis of covariance or ANCOVA models and the times in which they might really help you by controlling for variability that you couldn't control for in a traditional ANOVA model. And so next we're going to talk about repeated measures ANOVA, which is another super useful tool that can make a big difference. So hope that helps, and talk to you soon.